So all we need to do is we need to come out with a counter example. So we're looking for two irrational numbers to multiply together. So they're saying it's always irrational. So we need to find one that's a rational one. Right, best example I can think here is root 2 multiplied by root 8, which equals, of course, root 16, plus minus 4. There's loads of examples that you could think of here, but it's probably the easiest thing to do is just to think of an even square number, and you know that root 2 is going to work. Right? These things quite often, just a couple of numbers rooted, multiplied together. Right, part B. Okay, so part B, it says sketch the graph. So this just means that x is always going to be positive, all right? We just take it to be positive value. So let's have a little think about what's going to happen. Well, there should be no debate about what's going to happen over there. Okay, that's y equals x plus 3. So we know that part there. Right, if I were to ignore the negatives here, the line would just go off like that. There we go. Right, part 2. So there's part 1 and part 2. So part 2 says explain why this must always be more than or equal to modulus of x plus 3. Well, it's probably easier just to look at the two graphs together. So I don't want to ruin this one. So if we just, so we know that that's going to be mod x plus 3. Now let's have a look and see what the other one's going to happen. Well, this side's going to be exactly the same, right? It's going to be no difference over here. The difference will happen here, and you'll carry on going here. These negatives will keep making it negative there. So if you imagine when we got -1, the -1 plus 3, and then you make it a positive. So it's going to keep on going down to here, and then we come up this way. So the best way of answering that question is probably just to draw a simple graph like this. Maybe write some sort of statement next to it. So when x is negative, it would subtract from the 3. Okay, I'll get you all the marks.